So this is just a quick mini lesson on New York State Reference Table F. So Reference Table F is all about determining whether or not ionic compounds are soluble in aqueous or water solutions. There are two parts to this table. One, shows the ions that are formed soluble compounds, and one that says ions that form insoluble compounds. Let me first start talking about the soluble compounds. So the first side, the left side here, says these ions, any ion that has as a component one of these things will form a soluble compound. Well, let's talk about it. Let's go through these one at a time, shall we? All right, so the first one here is the group 1 ions. Anything that is a group 1 has a group 1 ion. Remember, group 1 is the first group in the periodic table, the most leftmost column. We're talking about lithium, sodium, potassium, rubidium, cesium, francium. Those compounds, any compound that has those, one of those ions as a component, that will be an absolutely soluble compound, okay? There are no exceptions for that. As you see right here, it says there are no exceptions. So they will all be soluble compounds. Similarly, ammonium, any compound that contains ammonium as a portion, as the cation, will be a soluble compound. Nitrates and acetates and hydrogen carbonates and chlorates, those are your anions. So any compound that has either nitrate, acetate, hydrogen carbonate, or a chlorate as its anion, so it makes no difference what the metal is, that will be a soluble compound. There are no exceptions, meaning there's no cases in which it would be insoluble. The next two here are the halides and the sulfates. So let's talk about halides first. Halides. Halides are your halogens. Remember, that's fluorine, chlorine, bromine, and iodine. All right, they don't mention fluorine here. But anytime you have an ionic compound that has fluorine, chlorine, bromine, or iodine as the anion, that's called a halide. And they are all going to be soluble, except if you have fluorine, chlorine, bromine, or iodine with silver, lead, or mercury. And in that case, they are insoluble. Those would not dissolve in water. But otherwise, they will dissolve in water. The last choices here are sulfates. If you have a sulfate, they are generally soluble in water, except when you have the cation that is silver, calcium, strontium, barium, or lead-2. Otherwise, it's going to be soluble. But with those specific 5, they will be insoluble. So they will not dissolve in water. All right? So that table there on the left side shows you all of the compounds that will have soluble compounds because meaning they do dissolve in water, with a few exceptions. This side is a little bit more confusing. This side says these are ions that form insoluble compounds, and then there are exceptions. And the exception means it's going to be insoluble except when it's not with these. So you're like, what? So it's like a double negative, and that's the part that makes this a little bit tricky. Well, let's talk about these one at a time. We already know that anytime we have a group 1 or ammonium, all right, we know that anytime you have group 1 or ammonium, that's going to be a soluble compound. And the same is true here. All of the carbonates are going to be insoluble, except if you pair them with one of the group 1 ions or ammonium. Then they will be soluble. Chromates are similar. If you have group 1 or ammonium, again, any compound that has a group 1 element, lithium, sodium, potassium, rubidium, cesium, anytime you have that in an ionic compound, it's going to be soluble. Similarly, ammonium, anytime you have ammonium as your cation, it's going to be soluble. But chromates say all chromates are insoluble except they are soluble if you have the group 1s and ammoniums, which we know. And then we're going to add a couple more. We're going to add calcium and magnesium. The calcium and magnesium chromates, they will be soluble. Phosphates and sulfides, they are all insoluble, again, unless you pair them with a group 1 or ammonium ion. All right, group 1 ions or ammoniums are always soluble, and so that makes the phosphates in those cases soluble, but in all other cases, those phosphates are insoluble. And then the last one are the hydroxides. Hydroxides are insoluble, except if you put a group 1 or ammonium paired with it, or calcium, barium, or strontium. All of those hydroxides will be soluble. All other hydroxides will be insoluble. So if you took a hydroxide with any other metal other than a group 1, calcium, barium, strontium, it would be insoluble. Okay? All right. So that brings up this worksheet that I have for you. This worksheet here is a Table F practice worksheet. In this worksheet, what you're going to do is you're going to look at each compound, and as you go through those compounds, you're going to say, all right, is that one soluble or insoluble? So let me just kind of minimize this a little bit so there's less information here for us. All right, so the first one here, aluminum sulfate. Aluminum sulfate. Well, down here on table F, I see, oh, sulfates, they're always soluble. Right here it says sulfates are all soluble except with silver. Well, we have aluminum. Calcium, nope, that's not it. So we don't have silver. We don't have calcium. We don't have strontium, barium. So this thing, aluminum sulfate, therefore it must be soluble. See how that works? The next one, potassium chromate. Well, one of the things I'm going to look for is I'm going to look and see if I recognize any of my group 1s, because group 1s I know are always soluble. And potassium is absolutely, that is a group 1 right there. So I don't even need to look at the next part, all right? I know this is already soluble. So now you can just continue working through this worksheet, looking for the ions that determine whether it's soluble or insoluble, and then work through that process. Great.